Problem 3. Solve for the value of x in the following equations. We have 3 equations, and they're all with exponents, but when we will be solving at the end, we will need logarithms as well. So let's review what the logarithm is. For example, if I have logarithm of 7 of 49, what does it ask me? What is this?
So what is the power you need to raise 7 to get 49? In this case, 2, because 7 squared is 49.
Mm-hmm. And then we can write it as the exponent 7 to the power of 2 is 49. So if we have an expression a to the power of b equals c, and we're trying to solve for the exponent, because you see, we will have x's everywhere in the exponents. So we will have this task of having exponential form, and we'll need to rewrite it as logarithmic form. So then what's the equation? The solution to this, if I'm rewriting it in terms of b equals something, it will be b equal logarithm of?
Equal logarithm of AC, A to the C.
A of C. A will be the base, C will be the argument. That's right. So these are equivalent expressions, just like in example with 7 and 49, these two were equivalent. So we will need to use this step at the end when we will be solving the equations. Let's look at the first one, A. What do you think we should do there first?
So for the first one, first we need to solve the equation for 7 to the x. Move 1 to the right. And then we divide both sides by 3, which would give us 7 to the x equals 4/3. And then we turn that into logarithm. So x equals log 7 of 4/3.
That's right, because logarithm asks 7 into what exponent equals to 4/3. So that's exactly the exponential statement. All right. And then we can enter it in the calculator to find the answer. Okay, part B. Here we have e to the x. That e is the Euler's number. And it's like pi, it's a never-ending number. It's 2718 ... We usually just round it to 2.7. So we can think it's a number between 2 and 3, and we will treat it as the number when solving this equation. So that's the equation now. What should we do with that?
So again, I think we should solve for e to the x. So we would subtract 1.
Subtract 1. Should we distribute 2 first on the right, or maybe multiply both sides by 2 so we don't have a fraction?
Sure. Yeah, we could do that. We'll have 10 times ex plus 2 equals 2 times ex plus 6.
I'm multiplying both sides by 2 because that will get rid of the denominator. Okay, so 10 e to the x plus 2
equals 2 times ex plus 3.
Okay, good.
Then we could subtract 2 from both sides, which would give us, that. Then we'd move 2 times ex to the other side, to the left. Yeah, and we would get 8 times ex. So we divide both sides by 8, and we'd get e to the x equals 1/8.
Mm-hmm. All right, now we need to change it into log because we are solving for the value of the exponent.
Yep. So we would get x equals log e of 1/8.
That's right. So that we just rewrote, and these two are equivalent expressions. And one more thing, when we have a natural log e, we write it as ln. So this is correct to write it this way, but much more standard way to write it ln of 1/8. ln means it's log base e. Okay, that's part B. Let's look at part C. In part C, we have 4 to the x and 2 to the x plus 1. And we also have a hint that this is a quadratic in 2 to the power of x. How is that a quadratic? We have 4 to the x and 2 to the x plus 1. Let's look at the terms first, how we can unite them. So this one, how can we simplify it? How can we get rid of the 1 in the exponent?
That's 2x times 2.
Because it's 2 to the 1 times 2 to the x. When we multiply with the same base, we add the exponent. So here we split. How do we turn 4 to the x? How do we relate it to 2 to the power of x?
2 to the power of x times 2 to the power of x.
That's right. Or we can say it 2 to the power of x squared. Either way, we'll use squared here only because they gave us a hint that this is a quadratic equation. So we're trying to get one term to be a square of another. So now it looks quadratic, right? Because we have this will be 2 times 2 to the x, and that will be 2 to the x squared. Let's do the replacement. Let's call a equals 2 to the x. And now the first term, which was 4 to the x, and we rewrote it like this, we can write as
a squared.
A squared, then minus
3 times 2a.
2 times a, because we split the middle term like that. And
plus 5 0.
All right, I'll multiply these two together. That will be 6. And here we have a quadratic equation. What should we do?
We could try to guess the numbers since they're fairly low. I feel like there would be negative a minus 5 times a minus 1.
So we wanted them to multiply to positive 5 and add up to negative 6. And yes, negative 5 and negative 1 work, we notice. So we will factor the equation. A minus 1, a minus 5 is equal to 0. Let's solve it.
Therefore, the two possible solutions are 1 and 5.
Now, once we know that a is either 5 or 1, we will go back to our substitution and we will solve for x. So first option is 2 to the x is equal to
1 and 5.
That's 1. And the second one is 2 to the x is equal to 5. Let's examine the first one. 2 to what power is equal to 1?
2 to the 0.
We know that a number to the 0th power is equal to 1. So here we just know that x is 0. And in the second equation, we need to change it into the logarithmic form. And
we'll have x equals log 2 of 5.
Log 2, the base, and the argument of 5. All right, very good. So these are our two solutions for part C.